You missed class and did not get the rest of the 7.2 notes, or perhaps you just are really excited about taking notes and want to know what's coming ahead so you can start your work a little faster in class. If that's the case, pay attention to this video clip on being able to apply properties of similar polygons to solve problems from lesson 7.2 of Calc Path Geometry. Find the length of the model to the nearest centimeter. We've done model problems before, or modeling problems before, involving scale factor. Now they've told us model, and they've told us the racing car. Well, when we deal with models or scale factors for models, it's a little bit different than for similar polygons and for items that have been dilated where we have an image and a pre-image. In this case, we assume the model is the image. We're modeling something based on the real thing we want to create, the pre-image. Or oftentimes we're doing a little bit of reverse engineering, that we have the car and we're trying to build a model to represent it. And then maybe we'll tweak the model, and we go back and forth all the time between building the model and using it to build the real item and doing the reverse. So that's where it gets a little confusing. But the scale factor for models is model over actual. Model over actual. So when they ask us to find the length of the model, there's actually several ratios we could do. We're assuming that the model and the racing car are proportional because you should always build the model to be proportional to the actual item. So again, since we're building the model, that's our image based on the actual shape. So image over pre-image kind of makes sense for model over actual. We're trying to find the length of the model car. So our ratio that I want, I'm going to be considering the length to the width of the car. Okay? Now there's two ways to do this. I can do length over width, and I can do, this is the way the non-traditional, not using the scale factor, of the model would be x over 6.3, and then the length and the width of the actual car would be 5 meters over 1.8 meters. Now it's okay that this is in centimeters and this is in meters, because if I have meters over meters, they really cancel out. And centimeters over centimeters, they really cancel out. So I could now set these equal to each other. My units are gone for now. I do know that in the end, since I'm solving for here, that was a unit that was in centimeters. All I have to do is cross multiply and solve. The other way that is accurate to set this up would actually follow the actual scale factor of a model to actual. Model to actual, I would say, well, we're doing model over actual. What are the lengths? Well, the length of this is x centimeters, and the length of this is 5 meters. So I have centimeters to meters. As long as I have centimeters to meters over here, it will still be an okay proportion for me to cross multiply and solve, and I don't have to worry so much about my units. Now I'm also going to compare the model to actual of the widths. The width of the model is 6.3. The actual is 1.8. So 6.3 centimeters to 1.8 meters. Now, units here match units here, units here match units here. We're good. Centimeters over meters, centimeters over meters. When we're done and we have solved for x, we'll have our answer in centimeters. So let's cross multiply. We're going to get 1.8x equals 5 times 6.3, which is 31.5. I could show you how the units cancel out also, but I'm going to let you take faith on it. If you want to see that, you can see me. I'll show you how they do here as well, how that it comes back to centimeters. To solve for x, we're going to divide by 1.8 on both sides, giving us x equals the quotient of 31.5 over 1.8, which is 17.5. 17.5 was for the model that we were solving, so this is 17.5 centimeters. The model's length is 17.5 centimeters. Example B, again, I'm going to, either one of these works. You could consider model to actual, model and actual doing length over width, which is what we might end up doing with some of the shapes that we solve in the next section, 7.3. Or you can do the scale factor for modeling problems, model over actual, compare their lengths, compare their widths, cross multiply. There are some other combinations of scale factors that do work to solve it correctly, and there are many that do not. Please use one of these two methods to set up your problem before you solve. Don't just randomly grab numbers and throw them into a proportion that may or may not be correct. For letter B, I'm again going to use scale factor to actual, model to actual, so I'm not going to do this method. I'm going to do model to actual. And I'm looking right now, I've got quadruple angle mark, those are congruent, triple angle mark, those are congruent, double angle mark, single angle congruency mark. I am solving for the value of x. This is the one that has the expression. It's between the single and double angle mark. So is the number 24. So those are corresponding. So on the single to double angle mark, my model is x. Also, they didn't tell me what the model is. That's a little annoying. We'll pretend that this was the model. We'll do x plus 1 over 24. And then I can grab any other numbers as long as they're corresponding. I see an 18 here, but that's between quadruple and triple. I don't have a number here, so I can't use it. But I could use this between the single and quadruple. Between single and quadruple, those are corresponding. Between single and quadruple, we've got 12 for what we're calling the model and 18 for the other one. When we cross multiply, I'm going to have to distribute this 18 to both the x and the 1, so I have 18x plus 18. And then I have the product of 12 and 24, which 12 times 24 is 288. From 288, I'm going to subtract 18. So this leaves me with 18x equals 270. To get our answer for x, we divide by 18, giving us x equals the quotient of 270 and 18, which is 15. That's all they asked us to solve for, so this is 15. Had they asked us to solve for this side, it would be 15 plus 1, which is 16. Again, like the very first benchmark test, be very careful when you solve problems like this on your quiz and BA, that you go back when you think you found the answer and check to see what you were actually supposed to find. Letter C, find the variable of x that makes the polygons similar. This is a side. It's between a single angle mark and a double. Its corresponding side is this, the 4. So I'm going to do this to this. I'll show you two ways to set this one up. So I did so I'm doing again, if I call this model and this actual, model over actual. And then here, the single mark to the non-mark, the single mark to the non-mark. And this is what we're doing to make sure that the ratios are the same, which would make the polygons similar, in this case triangles. The model is x plus 3. The actual is x. Now, the alternate way to set this up is to do the ratios of these sides. So I've got x over x plus 3 and 4 over x. So I do this to this and this to this. So you could, if you wanted, x over x plus 3 equals 4 over x. That would also be a correct way to set it up. Short over long, short over long. Short over long on the model, short over long on the actual. Well, we're going to run into a little bit of a problem because we did not cover this one algebra unit, but everyone should at least be able to set it up. Some of you are already able to solve it. The product of x and x is x squared. The product of 4 and the quantity x plus 3 is 4x plus 12. This is a quadratic. It has both an x and an x squared. So to solve, we need to get it to equal to 0. So I'm going to subtract 4x and subtract 12 from both sides. I will factor this, but at this point, since we have not reviewed solving quadratics, either by factoring or quadratic formula, I would not expect you to get beyond here for now. So we're going to, and if we have, then you need to be able to do that. So this is going to be x. If I factor this, factors of x squared are x and x. Of 12 are 4 and 3, which won't add to 4, or 6 and 2, which could subtract to 4 if the 6 is negative and the 2 is positive. We're going to set that equal to 0. Since this times this equals 0 using zero product property, either x minus 6 equals 0 or x plus 2 equals 0. If it's x minus 6 equals 0, when I add x to both sides, I'm going to get x equals 6. If it's x plus 2 equals 0, when I subtract x from both sides, I'm going to get x equals negative 2. Now there's a reason the or is there. Sometimes I plug it in, and both answers are solutions. Sometimes neither is a solution, and sometimes just one is. Well, if I plug in 6, I can have a side length of 6 here, and a side length of 9 here, and a side length of 6 here. My proportions will work out. Here, if I plug in negative 2, this works out, giving me 1, but this and this, I can't have a distance be a negative value. So that's what we call an extraneous solution. The only solution for this is that x equals 6, for the triangles to have real sides, not negative lengths for their sides. When you get to class, you will be asked to try these 4 problems and compare with your group members. Have a great day.